Good morning, all of you. Today we are going to discuss block diagram reduction techniques. Okay, continuation class of previous class. Okay, so subject control systems. Okay, so let us complete all rules of block diagram reduction techniques. Okay, after that we will solve the problems on this topic. Okay, rule 5. Okay, we will see the summing point. Summing point. So summing point represents summation of two or more signals entering into a system. Okay, and see the output of summing point being sum of the entering the inputs, as we already discussed in the previous also. So let us see one point on that. Summing point represents the summing point represents summation of two or more signals entering in a system. Okay, so which means what? We will write a summing point here. For example, this is my summing point. Okay, now this is one of the input. For example, this is another one, and this is another one. Okay, this is R of S, for example, this is X of S, and say this is Y of S. Okay, and say this is minus, plus, plus. Okay, then this will be moved. This is C of S. Right, now what is the output now? What is the output now? R of S plus X of S minus Y of S, because at this summing point we have negative sign. Okay, so this is the summing point, summing addition or subtraction. Okay, of a more than two signals, two or more than two signals. Okay, now this is the summing point, rule 5. Okay, now we will see the rule 6. Okay, rule 6, moving the summing point ahead of the block. Again we will see. Moving the summing point ahead or after of the block. Okay, moving the summing point ahead of the block. Now see that also. Now I have an input like this. Okay, and we have a summing point here. Okay, and we have one function here, functional block C of S. Right, now this is input R of S. Okay, and here we have, say, this another signal adding here. Okay, that is X of S. Okay, so for example both are summing. Okay, this is the direction here. Now we need to check what we need to do. My aim is I want to move this summing point after the block or ahead of this block particular. I want to move here. Okay, the summing point here to here to here. Right, so let us see the functionality first. What is the functionality here? R of S. So what is the output? This is error signal, basically it called output of the summing point. So both are summation. So R of S plus what is that? X of S. Okay, output of this one is the multiplication, right? So what is this one? G of S into R of S plus x of s. Okay, now let us see the modification after moving the summing point after the block, given block G. So let us see the equivalent block diagram, okay, after alteration. So let you take this one. This is the functional block G of S, and this is our summing point which we are moved before to after the block. Okay, this is a C of S. Okay, and here see we have another input X of S. Okay, so whenever you moved this particular summing point after to before to after the block, then here we need to add extra block, that whatever the block we have represented here, G of S. Okay, and both are here positive. This is input. Okay, now we'll check the input output relations. So what I did, initially we have summing point here. This summing point I moved after the block, this G of S. That's why here we need to add another input G of S. Okay, now check the functionality here. What is the output here at this point? R of S into G of S. Okay, so now this is X of S as given here, right? So output of the here, what is that? X of S into G of S. Okay, now is our summing point, both are positive. You need to sum these values, R of S into G of S plus X of S into G of S. That is our output, right? So I am writing here R of S into G of S plus X of S into G of S. So take common G of S, then it becomes R of S plus X of S. Okay, so see here, what is the output here? Before alteration, when summing point is at this point before the block, G of S into R of S plus X of S. See, after alteration we have G of S into R of plus X of S. Okay, so the outputs are not altered, outputs are same. Okay, so whenever you want to move the summing point after the block, you need to add extra block here, okay, which is in the series G of S. Okay, G of S I added here, right? This is the rule 6, moving the summing point after the block or ahead of the block, right? Okay, let us see the rule 7. Okay, so let us see the rule 7, block diagram reduction techniques, rule 7. Okay, so in this rule we'll see moving the summing point before the block. Okay, in the previous one after the block, so here the before the block. Moving the summing point before the block. Okay, so let us see that also. So I am writing here, this is my input, this is the function G of S, say, and this is my summing point, and this is output C of S. Okay, and we'll consider both are positive, and for this one same we'll take X of S. Okay, now this is R of S. So what I want to do, we want to move the summing point before the block, okay, which is already exists in the after the block, this particular block. So I want to move this one into here to before the block. Okay, so let us see the equivalent block. Okay, so before that let us see the input output relationships, and here at this point the output is R of S into G of S, and here X of S is another input, adding another signal here with the summation. So output of the summation is R of S, G of S plus X of S. So output is R of S, G of S plus X of s. Okay, right. Now we'll see the equivalent diagram here. Now we'll see the equivalent block diagram. Okay, right. See here, before the block I want to move. This is input and the summing point moved before the block. So here is the summing point and this is the block g of s, right? So this is our output. Okay, so whenever you move the summing point to before the block g of s, then we need to include here the function 1 by g of s. Okay, I want to move this up, right? 1 by g of s. Now as it is, this is input, another input x of s, so this is r of s. Okay, so both are summation given as given, right? So see here, whenever you moved, initially we have summing point here. Okay, so I moved summing point before the block of g of s. Then in another way, whatever the inputs coming to the summing point, you need to add 1 by g of s. Okay, right. So let us see the functionality. So what is the output at this point? X of s divided by g of s, right? And this is r of s. Now what is the output of the summing point? So output of the summing point is here r of s plus, both are positives, so x of s divided by g of s. Okay, now what is the output here? So here function we have g of s into r of s plus x of s divided by g of s. Okay, now minimize this one. So g of s into r of s plus, these both are get cancels, that is g of s. I will write again x of s g of s. Therefore, so what is the final value? R of s into g of s plus x of s. So this is the c of s value, right? So let us see. See, this is the output. Okay, when the summing point is before the, after the block. Okay, so the summing point I moved to after the block here, right? So after moving this summing point here, see, this is the output again. So both are same, these both are same, right? So whenever you want to move the summing point before block, you need to do this operation. Okay, right. So what is the rule number? This one, rule number 7. Okay, so we'll move to the rule number 8. Next we'll see rule 8. Okay, so see, we have almost all these rules, okay, use it to reduce the blocks, okay, system overall system blocks into a minimized value, that is the transfer function. From that we need to find transfer function, right? So rule 8 we will see interchanging the summing points. So let us see interchanging the summing point. Suppose I have two summing points here. So I would like to name the summing point x1 and this is x2. Okay, I have this one, say this is z of s, and for example say this one is y of s, and as you know this is input r of s and this is c of s. Okay, so we will see the signs. For example, this is both are positive and this positive. For example, this is a negative, right? Now I named the summing points here. This is x1 and this is x2. What I want to do, I want to move this one to here and this one to here, interchange as per my requirement. Okay, in the problem, okay, in the reduction technique, okay, in the system, I want to change, I need to change my summing point, one summing point. I want to interchange this, okay, for example, as per my need, then we can do this operation, right? So here what you need to check the functionality, input output functionality. So what is the output here? Both are sum, r of s plus y of s. Summing point will add. Here what is the output? See here, r of s plus y of s minus, this is a minus sign here, z of s. That is the output, right? So I will rewrite here r of s plus y of s minus z of s. Okay, this is the output. Let us see after interchanging what is the values. Now this equivalent diagram or block, so this is one summing point, another summing point, and the output C of s. This is r of s. Now this is I can say, sorry, here I can write this is x2 and this is x1. Okay, interchange it. Here this is x2 and this is x1. Here this is x2, this is x1, which means what? I interchange this one, both interchanged, right? So let us see. X1 consists of what? Both are positive. This is y of s, and x2 consists another input z of s. So this is the negative value. Okay, now let us check the functionality. I interchange the summing points. What is the output at this point? This point, r of s minus here, so r of s minus z of s. Okay, now at this point what is the output? So y of s is coming another as another input, so with the positive sign, so r of s minus z of s plus y of s. Okay, so that is the C of s. C of s output is equal to r of s plus, I am writing in order, y of s minus z of s. Okay, see here, after interchanging the outputs are same. Okay, the outputs are not altered. Okay, so whenever you want to interchange, you need to interchange like this. Okay, this is the rule 8. We'll see rule 9. Rule 9 is what? Shifting a takeoff point or summing point sorry, takeoff point or branch point, I can say. I will write here in this case takeoff point, from a position after a summing point to a position before summing point. Okay, before the summing point. Okay, see here. Rule 9, shifting a takeoff point or a branch point from a position after the summing point to before the summing point. Sorry. Okay, let us see the blocks here. this is my input, and we have a summing point here, R of S, okay, and this is my output, say C of S, okay, and we have a branch point here, okay. In the previous rules we moved summing point. In this case I want to move summing point to before the block, okay. So which means what, I want to move this one to here, okay, before the, sorry, not block, summing point, right? So okay, this is our another feed forward path, I can say, okay. Now let us check the functionality, and we'll take another input data, okay. So both are positive signs. If I take both are positive signs, right? Now check the functionality here. Output of this point, output of the summing point, the comparison of both signals R of S plus X of S, okay. Now this is moving same like this, so here in this case R of S plus X of S, and the output also it is same, R of S plus X of S, right? Okay, let us see equivalent diagram, okay, equivalent block diagram for this one. Right, so whenever you moved, this is our summing point, and say this is our output C of S. So this is my branch point now, which is moved from here, okay, after to before a summing point, okay. So this is as it is. We have X of S with the positive sign. Then this is, see here we have a feed forward path. So this is, we have a feed forward path. In this what will happen, in this what we need to add another summing point with the value of X of S. Okay, with the value X of S, and this will move to further, right, another part of the graph, right? So this is the shifting, I mean moving branch point before the summing point, okay. So this is R of S, right, indication you need to show, okay. Let us see the functionality. Let us see the functionality. So this is moving like this, okay. So see here, what is the value, R of S, both are sum, you can take sum, X of S. So output of this one R of S plus X of S, okay, and output of this one will be R of S plus X of S, same. So C of S is equal to here what, R of S plus X of S. See the both blocks, here is the output, C of S is equal to X of R of S plus X of S, same output we got, and here also we got the same output, right? So this is rule number 9, okay. Now we will see rule number 10. Rule number 10, that is what, elimination of feedback loop, okay. So this is very important. Anyway, we studied in the previous class, we studied about closed loop transfer function, okay. So loop nothing but it is a closed path, right? So let us see, here is summing point, and this is forward path G of S, and the output C of S, okay, and this is R of S, okay. Now we have a feedback here, say H of S, and see here this is moving like this, right? So here I am taking positive and negative feedback. Okay. So this is generally, as we know, this is forward path. Okay, already you know this one, and this one is a feedback path, right? Now let us check the functionality of this one. At this point, what is the output? R of s minus, so let us see this one. What is the output at this point? C of s into h of s, C of s into h of s. Okay, so this is feedback path. See here, feedback path. For feedback path, what is the input? Input is the C of s and the output is, okay, we are connecting here this point, right? So they are multiplication, both C of s into h of s. Okay, therefore R of s, output of the summing point is C of s into h of s. Okay, now what is the C of s? G of s into R of s minus C of s into h of s. This is the value. Okay, output we have this value. Let us see. I would like to minimize this value. Okay, let us minimize this one. Okay, this C of s value. So I am writing here C of s is equal to G of s into R of s minus C of s into h of s. Okay, so expand this one. C of s is equal to G of s into R of s minus G of s into C of s into h of s, right? So move this value to left hand side. So C of s plus G of s into C of s into h of s is equal to G of s into R of s. Okay, now take common C of s here. So 1 plus G of s into h of s. Okay, which is equal to G of s into R of s. Okay, now C of s is equal to G of s into R of s whole divided by 1 plus G of s into h of s. Okay, right. So therefore C of s is equal to this value. Still we would like to find the transfer function. R of s is equal to, this is the closed loop. Okay, when you reduce as a single block. Okay, so this is the C of s is equal to G of s into R of s divided by 1 plus G of s into h of s. Okay, then this is nothing but a transfer function, G of s divided by 1 plus G of s into h of s. Okay, so let us see. Okay, let us see the equivalent block of this one, right? Okay, right, equivalent block of this one. So this is the elimination of feedback loop will be, this is G of s divided by 1 plus G of s into h of s. See here we took 1 plus, which is nothing but negative feedback, right? C of s, this is the input, R of s. Okay, so what is the output here? So multiplication of input and the functionality. So this is nothing but R of s into G of s divided by 1 plus G of s into h of s. Okay, now we can write the as a form of transfer function, C of s output by input, R of s, which is nothing but G of s divided by 1 plus G of s into h of s. Okay, See, after alteration, see here, this is my output and this is also same output. Okay, so this is the rule 10, which is nothing but elimination of feedback loop. Okay, so elimination of, whenever you have closed path means what? The the path starts at a point, okay, and moves entire entire part of the graph or block diagram, okay, and terminates at the same point. Condition is whatever the branch or path, okay, should not cross more than once. Okay, right. This is the elimination of feedback loop. Okay, now we'll see the rule 11. Rule 11. Okay, let us see rule 11. Rule never splitting the summing point. Okay, sorry. Okay. Splitting the summing point. Splitting the summing point. Okay, let us see. Suppose we have a summing point with the values, this is a R of S, this is a X of S, this is a Y of S, okay, and the output we have C of S. Okay, so here say these two are positive and say this is negative. Okay, so splitting the summing point. So instead of one summing point, this point I want to two summing points here in this case, for example, right? So therefore we can split this one. So let us see the, before going to draw the diagram, let us see the functionality, input output functionality. What is the output here? Direct summation R of S plus X of S minus Y of S, because it is negative here, right? So now we will see the equivalent diagram, right? Now this is one summing point and this is another summing point. Let's say this is output C of S, this is input R of S. Okay, now at this point we have Y of S, negative, positive, okay, and this is X of S, both are positive signs. Okay, now we'll see the relationship after splitting. At this point what is the value? R of S plus X of S, right? At this point what is the value? So this Y of S will be added, so I will write that into directly at the output, R of S plus X of S minus Y of S. See, after splitting the summing point the outputs are same. Okay, so this is the rule 11. Now we'll see rule 12. So this is the last rule, combining the summing points. Combining the summing points. Okay, let us see the summing point. Same in the above. This is C of S, R of S. So for example, we have this X of S, and here it is the Y of S. Okay, so for example, take both are positive. Okay, and here better consider one negative value. Okay, now see the output functionality. So at this point, what is the value? R of s plus x of s, and the output will be R of s plus x of s minus y of s. Okay, now we will see how to combine these values. So the equivalent block diagram will be only one summing point I am taking here. Okay, this is x of s value, this is y of s value, this is input, and this value will be output c of s. Okay, this is x of s, r of s, y of s. Okay, so this is plus plus minus. So what is the output directly? We have r of s plus x of s minus y of s after combining the summing points. Here 1, 2 are the summing points, only here we have only one summing point, right? See here, after modification we have the same output. Okay, so this is the rule 12 of block diagram reduction technique. Okay, so these all 12 rules are very important, okay, to find the transfer function of given block diagram, okay, containing n number of blocks. Okay, one more point. So in the next class we will see the solutions problems on block diagram reduction technique, okay, or block diagram algebra, right? Thank you.